Okay. Greetings in the love and light of the infinite creator. I'm Andrii Zvorygin, joined today with Charles Hall and Jean Laherrère and Roger Bentley and Dan Gowan. And they will be presenting about a presentation on peak oil. Okay. Go ahead, Charlie.
Are you recording now?
Yes, it's live. Yes, there's people watching.
Okay. Hi, my face has disappeared, but here's my screen.
Okay.
And I just wanted to say this was a picture that was in my hometown newspaper about 1955, and I just was really interested in water and fishing and anything to do with that. And this was kind of unfocused until I met this guy, Howard Odom. And he's sort of doctor of systems ecology and energy at the University of North Carolina. And after a rather undistinguished academic career, or slightly distinguished only, I met him, and after some effort, I found this beautiful stream that was New Hope Creek in Duke Forest, and I put what's called a weir, which is a barrier. Now, I made more complicated ones later. This is my early model, and the stream is normally clear. This had been raining a bit, and I blocked off the stream at an angle and caught the fish moving upstream and downstream. And that's when fish were not supposed to be moving. But I found very, very strong movements of the fish, 21 species that lived in there. And while I was undertaking these analyses, and while I was sitting on these rocks at night, because I took a lot of oxygen samples around the clock to measure the metabolism of the entire ecosystem, I came up with the idea of energy return on investment. How much energy were the fish investing in their migration versus how much were they gaining from the migration at different points in their life cycle? And so that's my minor claim to fame, which we'll talk about a little bit more. And I captured and weighed some 10,000 fish.
Wow.
And took many thousands of Winklers, which are chemical means of measuring oxygen. Then about a decade later, when I was a young professor, I had a student who got me interested in applying these ideas. That was Cutler Cleveland's gone on and become rather famous in his own way. And we did this paper. He did this as an undergraduate. And this was the beginning of applying energy return on investment to looking for oil. And we found that the harder you looked, the lower your efficiency. And we'll talk a little bit more about that. And this was reported on the first page of the Wall Street Journal. And so I got quite a bit of attention. Increased drilling may not be in the national interest, a new study by two Cornell University scientists says, et cetera, et cetera. And we went on and examined that much more and wrote this paper, which had lots of estimates of energy return on investment, and began to look at the whole economy from an energy and what we call biophysical perspective. And these two, Cleveland and Kaufman, were my students, and Costanza was a colleague. And we published that on the first page, on the cover issue of Science magazine. This is a little bit misleading because the original picture shows a car lot full of dead cars. that was the intent. But anyway, I may be the only person ever to be denied tenure at an Ivy League university on the week I had the cover issue of Science.
Wow.
And so the importance, from Odom, I began to understand the importance of energy and all the things we do. And just to give you a thumbnail assessment, this is a 33 horsepower harvester from about early 1900s. And this took 5 workers plus stable boys and growing of the fodder for the horses or mules and so forth and so on. And then this is a 200 horsepower harvester. So it's 7 times larger, controlled by one person, but using oil. And this, of course, has enormous influences, not just in agriculture, but every place in our life. So this that completely changed our economy, and
that looks like a small.
I've written a lot of books on that and so forth. So while everybody else is most concerned about CO2, I'm most concerned about depletion, because we're so dependent upon oil for all the things that we do, and I published this paper in Bulletin of the Atomic Scientists in 1975 with an estimate of how much oil we would have, with a peak sometime after 2000, and gas following, and then a lot of coal. And it's not the oil number and the gas number look about right. So I've understood this from 1975, and the coal might not be as large as we have here. I haven't really examined what the latest estimates are versus this. Okay, so that's a background. And so I've been thinking about these Hubbard curves, so-called Hubbard curves. And then I've met in about 2000 Jean Laherrère, and we're, I think, and Roger's somewhat after, and I think we're all become quite good friends and very interested in trying to get the best estimate we can of how much oil there is. And so I'm starting by reporting on the paper that we published in 2022, turned down by Nature, of course. But the graphs give the main story. And the first is the growth in our use of oil over time. And we were increasing at 7 point. And incidentally, I'd like to say, relative to Roger and Jean, they know much more than I about these things. I'm a little more facile in English than Jean. I'm not sure about Roger. So I'm giving the first report here. And Jean is a master with graphics and data. And here is the data until the 1973 oil crisis, so-called oil crisis, which really is a big issue, a big point in human history. And we stopped increasing exponentially and have increased since then approximately linearly at a much lower rate, but from a very high level. And the production of global GDP is about the same curve. Now, I was born in 1943. So we are now using, well, let's just say from 1950, when I was 7 years old, we're 1, 2, 3, 4, 5, 6, 7. We're using 7 times more oil. It's just an astonishing change in human situation, but we all know that. Now, the first thing we did in this paper is we had to define what oil was. because it was lots of things that were different things to different people. And so conventional oil, which is mostly what people talk about, is crude oil, but it also includes natural gas liquids. When you take natural gas out of the ground, reduce the pressure, then butane and propane and butane and pentane and hexane and so forth fall out as liquids, and you can put that into a refinery and make various kinds of oil products out of that, including gasoline, if you do it right. And crude oil includes what's called light tight oil, which is fracked oil, and I'm going to talk about that specifically, and then conventional crude, I suppose. And you got to be careful because a lot of people talk about liquid supply, and we will too, which will include biofuels and other sorts of things. And there's what are called refinery processing gains. You get an expansion of volume, but not of energy content in the process of refining. So we got to think about the different types of oil when we're thinking about what we're doing. Now, here we have the official estimates from British Petroleum and Energy Inventory, I don't know, Association Oil and Gas Journal. That's official, I suppose. And that shows that the oil quantity of oil that we have remaining improved oil reserves is increasing over time. Now, that just didn't make sense to me until John explained it, and I'll try to explain it to you. Now, the first thing is here, the green is the rate at which we have found oil, conventional oil, and it has gone through its own Hubbard curve with a peak in around 1965 or so. And you see a really big jump here in 1948 when we found Ghawar, the largest field in Saudi Arabia. And the red line is the rate at which we've used it. Now, you notice that in the 1960s and 1970s, we found more than we used. And so our reserves accumulated. And then starting in 1980 and going down to today and continuing, by the way, we found much less oil than we used. So the important thing to keep in mind is the integral between the red and the green up to around 1980 or 85. This integrated area here is what we are drawing on since 1985 as we use more oil than we find. So this curve made no sense to me. Why is that increasing? And so John explained it, that what they do, first of all, when you find an oil well, find an oil field, they don't report the entire size of the oil field, they only a tiny part of it when they make the initial strike. And then what they do is subsequently they have revisions and extensions or new pools in old fields. They add these, which is the majority of oil we quote unquote find is from the expanding our knowledge of the original field. And so what they're doing, this red line, i.e. the official line, is including the year that the revisions and extensions are added to our so-called finding rate of oil. But when you do the proper way, is to my knowledge, only Jean does, is you take the revisions and extensions and put them as finding back to the year in which you actually made the initial strike of the field. And then you get a very different curve. Most importantly, it has peaked around 1985 and has declined since then. So the official estimates of oil from BP and oil and gas journal and so forth have it increasing. So not to worry, we're finding more oil over time. But in fact, if you do the proper correction of your revision and extensions, which is normally about 80% of the oil found in any year, to the year in which the field was found, you get a very, very different curve, one that has a peak reserves, and is declining rather precipitously. And so that's a very different situation. So we went out to try to estimate what the total amount of oil might be in the future. And we will talk about, right now I'm talking about conventional oil, but we'll talk about the other types in some detail. Now, the estimate we use to make projections of total all liquids, crude oil minus extra heavy, i.e. Canadian and Venezuelan heavy oils, are corrected again for those, and also for light tight oil, or what we call fracked oil. And the Hubbard linearization, which Hubbard derived, is an amazing method of extending. It's the change in production over the cumulative production versus cumulative production. And where that line intercepts cumulative production is what the total amount would be. So this is all oil, including extra heavy and fracked and everything else. And this is just crude oil, 3,500 of which we've found and extracted 1,500. Or if you correct for light tight oil, it goes down a little bit to 3,000, of which we've used half. And this one, I'm sorry, is crude oil alone, not including light tight. And that gives you an estimate between 3,500, 3,000 and 2,500. So this assumes that light tight oil will be 500. And so we project, we plot that, and John has some mathematical techniques for taking a total quantity, i.e. the point of interception for each of these lines. And incidentally, that's controversial, but I think I believe in it more as time goes on. And I spent a lot of time trying to figure it out, thinking about it. And so our estimates of how much oil, and this was at the time of our publication, and this is, purple is at 2020, as of 2020, just crude oil. And this is an estimate of how much we would produce in the future from Jean's mathematical technique. The blue includes fracked oil or light tight oil. Green includes extra heavy from Canada and from Venezuela, of which there is a lot, but it is thought to be a rate limited versus a quantity limited project. And here, I think one of the important things of our title of our paper was showing the importance of natural gas liquids. So we do not peak until maybe 2040 if you include the natural gas liquids and the other stuff. So we have a peak in conventional oil, but not a peak in all oil, or all liquids, I should say, to be consistent with my own terminology, including natural gas liquids. Now, we have in fact had a peak in conventional oil as ASPO, Association for the Study of Peak Oil, and John and Colin Clark and others said, since about 2005, it's been a plateau of conventional oil. But there are these other things, and it's these other things that mean that we are not in a existential crisis of industrial civilization at this time. And here's our estimates versus some other world oil estimate and WEO. Somebody explain exactly what that is. I don't remember. And
World Energy Outlook.
Okay, thank you. Now, I've used 20 minutes. I'm going to use 10 more minutes talking about fracking, which has saved the United States' ass. So let's talk about geology. First of all, this is a great book. Because we're talking about geology, I want to tell everybody this is a marvelous book about geology. Now, this is from Colin Campbell, who certainly has been responsible for anything of utility in what we say, as well as Jean. And this is petroleum geology in 3 minutes. You start in general with a period of a very great global warming and a rift, like when Scotland went sailing away from Norway, or what might be happening in East Africa now. And if you have to have extreme global warming because you can't have the surface waters mix into the deep waters. The important thing is you get large growth of algae going to the bottom of a deep lake or marine area and piling up down there and not getting oxidized. Most phytoplankton that grow are oxidized within the year or so. But if you have a stratified, you can't mix hot water or warm water into cold water. You get cold depths and no oxygen, big accumulation of organic debris, and then you have to have sediments coming in from the land. And you then have to have a period of excessive erosion to fill the rifts with sediment. And then you pressure cook this algae for 100 million years or 150 million years, and you get oil. And what you get is in oil fields that we have used traditionally are normally what are called traps, where you have an anticline, a geological anticline or fault or something, and you have an impermeable seal that's certain kinds of sandstone or salt or whatever. And if you have this trap underneath, you accumulate oil, which is lighter than water, and gas, and underneath it is water. So you get a layer of oil about 2 miles deep. You have perfect temperatures, about 100 degrees Celsius, to make oil. And when gas is just oil that's cracked or split into little pieces. And then we have an oil well, and up at the top, where we have wells for water are just little areas up at the surface. Now, what happens that these pictures by Colin don't emphasize enough is you have the source rocks where it's made, where the oil is made, and then it migrates. If you have the right temperature to form oil, the oil and the gas will migrate up to a trap. And so these are what we've exploited so far. And we've really exploited it. This is the number of oil and gas wells that have been drilled in the United States and in Canada. And obviously a very large number.
Mm-hmm.
And the production of oil in the United States from 1950 to 2000 and something, um, originally our production increased with more drilling, more feet we drilled each year. But then when the number of feet declined, the price of oil went down. People didn't look for it so much. We still continued to produce more and more conventional oil until 1970 or 71 or so, as Hubbard had predicted. And then it declined, and it declined even though, and this little bump here is due to Alaska, it declined even though we drilled enormously more. We drilled 3 times more, but we did not produce any more oil from the drilling. So what's important is not how many feet you drill. So the president says drill, drill, drill. That might be a little bit different with fracking. We'll talk about that. But for conventional oil, that is not true. Now, we made predictions of global energy return on investment for producing oil and gas. There are various ones that we did, that we undertook, and the energy return on investment, going back to the fish, appeared to be declining sharply, may still be. The amount of oil left in the world, here's the US. You see, the US is not very important. Yet we're very important right now in production, not in reserves, but in production. So this guy, George Mitchell, his daughter, he was an oil man, and his daughter was sucking on a milkshake, and then she'd turn her straw upside down to get the last bit at the bottom of the glass. Gave him the idea of going down vertically, which is all we had done, well, mostly what we'd done previous to that, and then making laterals that go out 1 to 2 miles and putting explosives in the pipes and then pumping down a huge pressure, 8 fire trucks in a row, that were in a series that were increasing the pressure on the rocks, would crack the rocks, and what this is source rocks. This is what the rocks themselves look like, and you got to crack these rocks and get out these little bits of oil, but you can do it over a huge 2-mile oil field, and that has saved the United States ass with respect to oil production. I guess 2022, we're right here somewhere, and you see that if we did not have fracked oil, we would be in very bad situation. This is conventional oil. The lower 48 has gone down to very little, only 10% of what it once was. Offshore is added a little bit more, but mostly we are now about 85% for oil. And I have to tell you that trying to figure out the oil supplies in the United States, we only produce 13 million barrels a day, but we use 20, and most of that is natural gas liquids. Until I understood the role of natural gas liquids, I didn't understand why we were using so much oil and we're still energy independent. It's fracked gas. Fracking has been even more important for gas than for oil, including natural gas liquids. So here's a fracking operation. It's a hugely energy intensive process, but this is a study by Adam Brandt, and he found that from 2006 to 2013, you had a Hubbard curve of EROI. In other words, that you got 35 or so on average from fracking, 35 to 1, where by that time conventional oil was below 10 to 1. So fracking saved your ass not only in quantity but also in energy return on investment. We get people think that fracking is so expensive, but you get so much oil in the first 2 or 3 years. The difference is with the conventional oil in the US in 2006, we're getting about 20,000 barrels a day from the wells, but with fracked wells, you get 200 or 400,000 barrels. I'm sorry, 20,000 barrels from the well over its lifetime. But you got 10 or 20 times that from a fracked well. So fracking has saved our ass. Here are the fields that appear to be important, and the Barnett was important initially. Most of these in Williston or Bakken seem to be very important, but they have peaked and gone down in a Hubbard curve. And what's really driving the oil now is the Permian Basin in Texas and New Mexico. And for gas, the Marcellus Formation and maybe the Utica Formation in Pennsylvania. Most of these other ones have sort of gone through their Hubbard cycle. The fracked fields look like this, a well every half mile for as far as you can see in different places in the United States. It's a huge, huge enterprise. And this was way back in 2010. You could see the various wells and their laterals plotted on a map in here of North Dakota and Montana. And just look at the density in which we're permeating, I guess that's right, the oil fields with our laterals. And you have to keep drilling to keep your total production up. So even if the wells become not as good over time, you drill a lot of them. But you got to remember that, and this is a paper by Steve Moore et al. In 2015, this is when you will die. Here's his estimate of all energy. Now, how accurate he is, I cannot tell, but the thing is, he gives you a median, a low, and a high estimate, and the time scale is a little different. It doesn't make a lot of difference on the history of humanity or even the history of the United States. This reduction in our availability of carbonaceous fuel is going to come up with us that if you take a longer view of oil, of all fossil fuel in the history of humans, this is when the steam engine was
tu me rappelles plus tard, j'écoute là.
And then I quote Upton Sinclair here: "It is difficult to get a man to understand something when his salary depends upon his not understanding it." So here we have another view of Hubbard's pimple. Here's pre-industrial for 3,000 years of hominoid evolution, and what will our future be? So the oil period is short. Now, people have various solutions, nuclear and so forth. I think applying fracking technology to 4 miles down to heat, deep geothermal heat, is an idea we need to explore more. I don't like nuclear for reasons that most people don't mention. And it offends the human ego that nature is indifferent to us. I've got all of this is developed in this book, which should be the basic textbook used in economics around the world, but it's not. My final professional goal is to roll that boulder of neoclassical economics off the cliff. And here's the end.
All right.
The end of the oil age. It's coming.
Yeah.
I'm done.
Yeah. All right. So any comments or questions? So we have 22 concurrent viewers, Charlie, for your...
Oh.
Yes.
That's pretty good. Hello, everybody.
All right. So Roger or Jean, did you have questions or comments on Charlie or Dan?
Jean, go ahead if you want, Jean.
Yeah, you just have to unmute because you took a call. I had to mute you.
Jean has updated these graphs, but I wanted to show the published ones.
Mm-hmm.
They don't show anything very different.
Jean, I'll happily follow
John,
you,
turn your
Jean.
microphone on.
Yeah. Okay.
John?
Oh, you have to turn on your microphone, Jean. You have to click on the little microphone icon.
On the screen, bottom of the screen.
You got it. You got it.
It's good. It's good.
Yeah.
Okay. Okay. So I'm happy because Charlie has shown most of my graph, and I will update my graph when I get new data.
Yeah.
But I have to wait for the IEA World Energy Outlook, which is supposed to be in October.
Mm-hmm. So I do have a question about that graph because it's different. The one that Charlie showed was from 2021, and this is the one I saw you posted in 2025, which has a very different peak. It peaks in 2025 to 2030.
Well, you see, this graph, I don't like it because if you focus the beauty of the graph, why do you have to all this?
That's COVID. That's COVID interrupted the beautiful symmetry of geology.
No, but it is the graph is okay. It is all the line, the green line.
Oh, the green lines I added
upsetting my view.
Oh, I'm sorry. I added the green lines just so that I could see which years it was related to.
Don't forget that in all or any natural measure, you have only you have a lot of uncertainty, and you have used only 2 significant digits. When you are making more than 3, it means it is outside the uncertainty. It means that use more to two digital digit is wrong.
Okay.
I didn't understand that. Could you say that again, John?
It means that for me, the uncertainty of the data is such that the only 2 first digits are real and the rest is peanuts.
Mm-hmm.
If you're lucky.
Right.
Yes.
Yes. Yeah. I was just noting because the graph that Charlie showed, the peak was in 2040, and the peak here is in closer to 2020.
No, because my graph included natural gas liquids.
This one also includes natural gas liquids, NGL. It's just this was in exajoules, and the other graph was in gigabarrels. And I thought that maybe Jean had updated it based on the energy content.
Yeah, and it will be updated in October.
And it'll be updated again in October. Okay, great. And Roger, did you have any commentary as well?
I do, Andrea. Yes, I do. First of all, can everybody hear me clearly?
Yeah.
Good. Charlie, just an outstandingly good presentation. I don't think I've ever seen one from any of us quite so comprehensive and good from the beginning to now. So I'm absolutely staggered, Charlie, how good it is. I'm very impressed. Better than
I agree.
Thanks to you and John, because I didn't generate. That's my role. If I do it well, and I'm glad you think I did, is to communicate.
Right. I got about 4 comments. Some are sensible, some not quite so, Andrea. Apologies. Mm-hmm. Just the other day on our holiday in Berlin, we went. We used a horse-drawn cart. You had a very nice picture, Charlie, of a 33 horse drawn thing. We went in a I'm just shocked how powerful a 2-horse drive. There were about 20 of us being pulled around Berlin, up hills, over cobblestones. 2 horses are pretty powerful. I'm impressed. Okay. Secondly, your plot that you had from our paper, it is ambiguous. It was from the EIA of the different types of oil. Just to warn all the listeners, we tend to say for conventional oil that we take out the light tight, but that in that one from the EIA, they put in the light tight. You just got to be careful, as we saw with the other graph, what is in and what is not in. But my papers, for instance, take out light tight from conventional, and that IEA chart had conventional in, but just be careful about that, everybody. That's 3. Importantly, we have just found out between us that very recently the US EIA, Energy Information Administration, has stopped reporting the proved oil reserves. They were a stalwart, along with Oil and Gas Journal of World Oil, reporting those rubbish proved reserves oil figures. I've just had information back from them saying that as of last year or possibly the year before, they don't report proved oil, and that is just an increasing group around the world, slowly, Charlie, coming back to what we've been pushing for years and years, slowly stopping the reporting of the proved oil reserves. And Andrii, you know that we're hoping to have a workshop, invite-only workshop under the aegis of the Energy Institute in London, hopefully sometime, to bring in all the publishers of oil reserves. I think it's going to be a bit of a shocker. Charlie, as you show, the probables, the reliable data have half the oil reserves. And I think once a newspaper or television picks up that the reliable oil reserves are half the published data, I think the thing's going to hit the fan. Andrii, can you hear me, or is there too much echo?
There is a lot of echo.
Everybody turn their mic off if you're not speaking.
And I'll go a little further away from, I think I'm talking too close to the phone. My apologies.
Yes.
So we're hoping, I'm pushing hard, whether the Energy Institute will do it. They've said they will, they're interested. It will be a step forward. Charlie and Andrew, you know, we're working hard trying to say that nobody's wicked in this area. That reserves reporting problem is not malfeasance. It's just the data reported differently by different groups for good solid reasons. And there just is no global standard so that anybody can report what they wanted effectively. But I think when it is discovered that the world's global reserves are half, the reliable data are half the published ones, I think it is going to cause a bit of a storm. And Charlie, your point too, not only the reserves half, but they've been going down, not up. That's two rather important points for the world to wake up to. We still know there's a lot of oil.
And the energy return on investment is declining.
Yes, that too. So I think, and I hope to do yet another mini paper on that, Charlie. So that's three important points. Proved oil reserves are twice what is in. So the reliable data are half the published ones. The numbers are going down, not up, and the energy return is declining. Those are fairly important messages to get across. Absolutely right. Okay, let me keep going. I'm nearly there. Backdated. You said Jean had the backdated oil reserves, and that's the numbers you need. In fact, that's how the data come from the big oil consultancies. If you go to what was IHS, now Standard & Poor, or go to the other ones, they all have the backdated data, so you can see when the oil was discovered. But it's a very good point you make, Jean. Yes, we had that. Harbert linearity reliability, Charlie, the thing you've done quite a lot of thinking about, how reliable those graphs are. There was some quite simple extra analysis that we ought to be doing that nobody's done. I asked Jean and some others. There's some quite extra, and I'll help to try and propose a paper on that so that we really can solidify. As Charlie says, Harbert linearization is an extraordinarily powerful technique. It does not work if you're discovering lots of new basins or whatever. But if you're in a place where your discovery really has gone over its own Hubbert curve, then just the ordinary production data, the simplest data you can imagine, you don't pay $100,000, you just get production data, and boy, oh boy, you have the answer. Amazing. Very small, quick one, Charlie. Kaufman was one of your good students, Charlie. That's correct, isn't he? Kaufman. Sorry, you're muted,
Yes,
Charlie.
yes, he was a wonderful student and a wonderful friend. Still is.
Yes. And so I've promised him. We had a quite a long email discussion some time back, where he didn't think that oil had plateaued at 2005 for any resource limits. He thought, oh, there's plenty more. It's just OPEC financial constraints. So I have got to send him our latest paper, Charlie, the one on Hubbert's forecasts, and then go back to him. So I'll copy you in, Charlie. I'll go back to Kaufman and chat to him about that. And then that is it. Thank you very kindly. A brilliant presentation, Charlie. Couldn't be a better one.
I want to add something about proven reserve.
Okay, go ahead.
Okay, now proven reserve is a minimum value. It's supposed to be the 90% probability. And so it is completely incorrect to aggregate proven reserve. The sum of proven reserve is not the proven reserve of the sum. So it is incorrect to add proven reserve. So it is what it is done by everybody, by Oil and Gas Journal, by EIA, by you have to add only 2P reserve.
Yes, quite right, Jean, quite right.
Yes. And then I actually wanted to share here. This is a summary from ChatGPT explaining why there's that big difference between the 1P and, okay, so what peak depends on what you count. So, well, conventional crude, that was in 2005, crude condensate 2018, all liquids, it's still maybe in the future, 2027, according to some Art Berman. And so here, quota wars inside OPEC 1988 to 99 added 50 to 70 billion barrels overnight. No new drilling, just bigger paper barrels to raise production quotas. And this adds 300 billion barrels to the 1P tally reported by the SEC. And then SEC rule change in 2009, U.S. companies allowed to book oil sands, shale, and other non-traditional barrels as proved if they can show a development plan and a 12-month price average. Another big boost to 1P. That's why, because of these rule changes, is why we see those large upward trends sometimes. No downward revision for production. More than 70 countries simply don't subtract annual output from their proved line numbers, meaning cumulative discoveries rather than remaining reserves for those countries. But it's confusing because some countries do report subtraction, like US and Canada, but more than 70 do not. And so you can't say that it's all discovery numbers, but it's basically it's a mix of the two. Then reserve growth accounting. When better seismic or higher oil prices lets you tap more of an oil field, those extra barrels are added to current 1P instead of being backdated to discovery. And that's a little bit was mentioned by Charlie, including extra heavy and Carrigan barrels. Venezuela, Orinoco Belt, and Canada's Athabasca oil sands relabeled proved once commercial upgraders existed, which added another 350 billion barrels. And so here we have anyways, but when you backdate them, then it what do you call it, the field tops out in 1985. So yeah, the bottom line, there we go. Anyhow, hope that adds a little bit of context for people.
Andrii, can I just add a quick one to that?
Sure.
Andrii?
Yeah.
Just very quickly, we're pretty sure, Colin Campbell's suspected for a long time, but we're pretty sure that some of those OPEC country numbers are the ones that don't change and are quite high, are indeed almost very likely, and I guess it will come out in some of these meetings we have, were the original proved the original oil in place reserves. So the original oil in place for those countries. So that's the maximum they ever had, and they've been going down ever since. And that is a good explanation for why the numbers don't change. They say this is what we had at the beginning, and this is what and we just don't tell you what we have now. And I think for some of them, 3, 4, or 5 of those countries, we're pretty sure that's the case. OPEC did ask all 3 big consultancies, the big consultancies, IHS, Rystad, and Wood Mackenzie, to advise them on reserves, but I've no idea what OPEC was told with those consultancy reports, and that's another thing we'd love to know. But anyway, some of those OPEC countries we think were the original in-place reserves, and that's why the numbers don't change, and that's why they're about double what they have, double what, for instance, Rystad has for them, so they have twice as much. Thank you, folks.
How can we get this into a short paper in Nature or somewhere, oil and gas journal somewhere, so that the newspapers pay attention to this? Just the oil reserves are half of what they say. How can we do that? It's got to be a short, sweet paper.
You're completely right, Charlie. Perhaps we ought to think Nature. I don't think we get into Nature, but we could probably get into Nature Energy with luck. I would think Nature Energy. And you're completely right. All the newspapers do read, and the television do read the latest reports from Nature and do publish them. So if we want keen to do that, okay.
I think John should be the first author, and I think that page that Andrii was showing was a good summary, I think, and it's just got to be 5 pages long, less than 5, 3 pages long, and it's saying oil reserves are half of what we're being told. That's got to be the title, something like that.
Yes. Well, the definition of reserve is very tough because you have several reserve classification. You have the SPE, you have the Russian. You see the Russian, it is not 2P, it is ABC1. You have the Norway classification. It's been the problem is it is very hard to get the good definition of what we are talking about.
Okay, but then our conclusion has to be we call for standards, for universal standards.
Charlie,
yes.
Charlie, you're talking about a problem that we've been talking about for a long time. For example, OPEC, they have what's called OPEC quotas versus the actual data we have out of Riots, what's actually coming out of these countries, right? Yeah. Every country except for like Saudi Arabia and UAE have not come up to have their production levels haven't come up, since the levels they had before the 2020. They haven't. In other words, here's what they're actually producing. Here's what their quotas are producing. Everybody in Wall Street's expecting these guys to produce quotas. For example, like Saudi Arabia, they have their quotas at 10 million barrels a day. We know for a fact they only produce 9, right? And whenever Saudi Arabia has a spurt in oil, one of the things the United States military we have infrared images of all the oil tanks and stuff around the Persian Gulf. We do it for military reasons, but we know for a fact that the Saudis can only produce 9 million barrels a day, even though they say it's 10. So this OPEC thing, here's what they say, but here's the reality, what they're doing. The spare capacity doesn't exist. It's not there. But everybody in Wall Street think there's 3 million barrels extra today. Something today happened had to do with India. Basically, Donald Trump increased the sanctions on India in 20 days. He'll increase to 50% tariffs in India for taking Russian oil. India takes 2 million barrels a day of Russian oil through the dark fleet. The Russians came back and said, if India doesn't take our 2 million barrels a day because of sanctions from the United States, the Russians are going to cut off the pipelines that bring in Kazakhstan. You take in Kazakhstan's 1.7 million barrels a day, India's 2 million. There's a shortage of 3.7 million barrels a day. Every bank on the planet from JP Morgan, Goldman Sachs has already screamed and told them the capacity's not there. We don't have it. If you put sanctions, you're going to crash the world's economy. It'll be $100 oil. I mean, that's how short we are. And it goes between, here's what these guys are saying. Here's the reality, what's actually being proved. There's no spare capacity. And it goes back to people aren't telling the truth about these production numbers. You're exactly right. You're muted, Charlie.
Yeah,
Put
Charlie.
your mic.
It was echoing on your computer, so I had to mute you, Charlie. Go ahead. Oh, you have to unmute first. Also, while Charlie figures out how to unmute, that there was some question about would link to the paper and if they explained why it was rejected from Nature or something. Charlie, it's the first button on the bottom of the screen.
All I'm saying is that Dan's ideas, and probably Dan himself, should be one of the authors of this paper. And I don't know if we want to make this one of these 10 authors.
All I'm quoting is stuff coming out of oilprice.com. I emailed you all the links to these articles.
Yeah. But you can summarize it.
Yeah.
I'm overwhelmed with all the stuff you send. There's so many bad things, but you can summarize it.
Right. That's all. Yeah.
So who's gonna write the guts of this paper? 3 pages.
Who has the guts to say OPEC's lying through their teeth? That's what you're telling me.
Omenikov. In your 3 pages.
Well, I mean, Jean, of course, should be probably the first author because he has the most credibility. But I don't think he wants to. He doesn't like to write. And
Omenikov.
I mean, I'm worried that it's going to come down to me, and I don't want to.
I want to ask you good news. Last week, BP has made a big discovery in Brazil offshore. It's supposed to be 500 meters deep, but I don't know what is the amount of oil and the amount of gas. But
it's part of the I did the same thing, John. It's part of the.
It's supposed to be CO2 also.
Yeah, it's high in CO2. The other thing about it is the oil companies had to build these huge radiator systems on the bottom of the ocean because the oil is so hot. If you bring it straight up and the oil comes in contact with the air, it'll catch fire. Right? So when everybody talks about the Campos and bringing that oil to market, I'm like, time out here. There are huge engineering issues here. So even if you discover new oil out there, it'll take you 10 years to get it, just for the sheer fact they got to cool off this oil before it can even come in contact with the air because it'll catch fire. So there's huge issue when you do offshore. That's what I'm getting at. So I saw the same thing. I said, time out here, 10 years before you see it. Just the engineering we have to do so we can bring that oil to market.
Is that subsalt oil?
Yeah. It's really deep. I've got the data on a lot of the wells. In fact, that goes into the geological studies that I did about doing geothermal power plants. Actually, come out of those wells because some of them are so deep. A lot of those wells are about 30 to 32,000 feet deep from the bottom of the ocean to the bottom of the well. The water's coming out of those wells over 500 degrees Fahrenheit. That's how hot the oil is. Yeah.
Oh, so a good source of geothermal energy, Don.
Yeah, the crude oil itself, yeah.
Yeah, run it through a heat exchanger and run a turbine.
300 miles off the coast, by the way.
Yeah.
Oh yeah, that won't work. That's a little too far.
Okay, Charlie, the number of times you've twisted my arm and criticized my documents and my book on oil, where you told me the whole front should be the back and the back should be the front. Once again, I will buckle down. My knees will graze the sand, and Dan, isn't it? Dan Gowen, I will write a 2 or 3. I agree. I'd love to have our Energy Institute meeting first with the invite only. Oh, but it'll take some time to get out in Nature Energy or something. Okay, let's have a very short 3-pager. Charlie, I don't want to be too dramatic. I don't want the world to go bonkers, and I don't want the oil companies or OPEC or anybody blamed. So we've got to have a fairly hefty paragraph saying this is just the way it happens to be. Nobody's wicked. It's just how the reporting went. But okay, I will go home. I'm on a lovely holiday in Germany, but I will go home and pencil a draft 2 or 3 pager only, Charlie. and then send it to you, and then you had deal with the actual editing with Dan and Jean. And if Jean wants a super new chart, well, okay, but anyway, step by step. And if we can get the righty thing out by when? This is August, September,
Well, we
October.
want
How about
John's date in October? We got to wait
Pardon?
for John's date in October.
Okay,
Well,
so then if we aim for October, so let's aim that it's actually submitted by November. How does that sound, Charlie? Does that suit you?
May I add something?
Yes, go ahead, John.
Okay, now you see the US refinery is designed to use a fairly heavy oil, and at the present time, US production is very light. So it's a problem, and they are obliged to import a lot of Canada oil from Canada oil sand. At the present time, Canada is sending 4 million barrels a day of oil to US.
5.
And
It's 5, John.
So the problem is the US refinery are not the good one for the present production, and there is a problem, and I don't know for how long Canada will help US to solve their problem of refining oil.
That's true, John. There's some serious political things going on right now up in Canada. They're having huge debates because I don't know what's going to happen in Canada, but there's a good chance the country of Canada could actually break up, because some of the provinces actually want to leave the rest of Canada is what's going on.
Dan, once it's the 51st state, then it solves all the problems, doesn't it?
I don't think they want to join the United States, but they are thinking about breaking
No
up.
way.
And it mainly has to do with so they can control their energy resources. So.
Yeah.
I know.
You know, when I was in Canada, I was the first Canadian company to explore oil in US, because I was using tax money from a Total refinery in Michigan. So it was funny because most of the exploration in Canada was made by American company, but at the time it was the contrary. It was.
Yep. Yes, sir. Michigan has 16,000 depleted oil and gas wells. 16,000 of them.
Andrii, you send that table you showed us, send that to Roger.
Okay, sure. And okay. Now, did someone else have a presentation they wanted to do? Dan, I know you've been collecting lots of news articles and such. I don't know.
All I wanted to talk about was the fact that yesterday Donald Trump upped the tariffs on India. So in 21 days, the tariffs will be 50%. India is between a rock and a hard space because there's no spare capacity in the world economy. The world's consuming 104 million barrels a day, 103 million barrels a day of crude oil, and they're getting it through the Black Fleet. And if you cut off that oil, then the Russians have already come back and said, look, then we're going to cut off Kazakhstan's oil, because the country of Kazakhstan is situated between China and Russia, and they use Russian oil assets to get their oil to market. The Russians are just going to shut it all down. So that means there will be a shortage of 3.7, maybe 4 million barrels of oil per day. And the traders have always said, if you cut off India, that'll be $80 oil. And if you cut off Kazakhstan, the oil will be over $100 a barrel and going higher. And that's how short the oil markets are. And even if you went out there and drilled and find some new oil, you still won't see that oil for another 6 to 12 months if you're lucky. So everybody's not understanding how hard it is to bring oil to the market, how much infrastructure it takes to bring it to the market. Or like down in Campos, down in Rio de Janeiro, bringing that oil to market. You have to put in all this engineering, all these structures. It's 300 miles out in the middle of the ocean, right? It'll take you 10 years before you see any of that production, because it's so expensive to put offshore oil, into the world's market. So that's the thing I have to remind people about. Even if you found oil today, you won't see it for 10 years. Even the stuff in Alaska, even if we know there's oil up there, we brought that stuff online, it'll be the 2030s before you see the oil. The oil markets are that tight.
All right. Thanks.
Okay, then Charlie, Andrew, then look, I don't go home for a while. I've got things to do, but reasonably quickly, in let's say 4 weeks, in 4 weeks, I will have it's got to be super short. It goes to probably Nature Energy, I suspect, but 4 weeks, I'll get something in your hands, which has two parts to it. It has a reserves thing that we've been talking about all this time. And then Don, it has your bit about production rates. So we just say something like big questions over oil supply. We've all written these things before, but if it goes to Nature Energy, it might get a bit of footage. I don't want people blamed. I don't want world panic. I don't want world wars to be started over all this. So we'll try and be cautious. I'd hate to see a world war started over oil supply because of these new data we're giving. So we've got to handle it very, very sensitively. But perhaps I do, Charlie, put something together and it comes to you and then to Dan. And by what do we say? Do we say after the IEAs come out, and Jean, you've had chance to do a graph or two, then we put it together for November or something. Does that sound sensible, Charlie?
Yep.
Sounds good.
Okay.
Yep.
So I wanted to, since we still have some time, I just want to go through this presentation, which is related. Like I presented it before, but I think that this crowd may understand it better. So this is based on Jean Laherrère's graph from January 2025. And we know that perhaps, in October, there will be some revisions and this might move around. But this kind of gives the idea of basically oil decline and what is the effect. Okay, so based on historical precedents, like in 2025, 22% oil decline, it caused a 25% oil increase. And then a consumer price index of 1% and the food price increase of 5%. Okay, so and then you can see the kind of differences here. So here, I just got to make sure. Okay, and then so for instance, post-pandemic recovery, when we saw that huge decline, and then instead of just letting people buy food more cheaply during deflation, they printed lots of money to prevent deflation, to protect the rich people. And then so when it came back online, anyways, that created a lot of inflation. And so we had 12% food inflation per year, I think 30% over the period. And then this is kind of gives a refined table of prices. This is for Canada. And of course, these are kind of tentative numbers. I guess I should have included fewer digits of accuracy according to Jean, which is true. So yeah, just look at the first two numbers, if you will.
You have to remove all the decimal.
Okay, yes, I'll remove.
Yes,
I'll remove all the decimals and the future and such.
No more than three.
Yes, this is kind of just to give you the general view. If things were to go along this graph, okay, so food as a percentage of income for a single person home, or like say a single income home in Canada. And so here in 2015, it was 23% and 28, and then 2025 to 2030, it would be 36, and then 49, and then 2035 to 2040 would be 70%. And then, well, obviously at this point, you won't be able to feed yourself. So we would have, this doesn't necessarily mean that, people will be dying of starvation, just that the current system will experience a transformation. It will be a different system than we have before. And okay, so that's another one. And this is kind of looking at individual incomes and how much purchasing power they have, global food prices per decade. And then this is living space, also looking at, how much land can be purchased. And this has a lot more to do with policy than it does. So for instance, I think I had this, in the Great Depression, land was cheaper and people were actually richer in terms of real value than they are now. Anyways, global living space. Okay, and so 2025. So assuming it goes by that graph, So the period we just went through, food prices rose 24%. Median households spend 28% on food, and then 1.5 to 3% of Canadians have enough land to grow their own food, and that's a policy issue. That's not that can be fixed through human right to land or something. And then so 2025 to 2030, if the plateau does happen, then the median household will be spending 35% on food. So this is kind of we can focus on community cohesion. It's kind of a plateau. It's not a big deal. Gasoline prices could increase, though they decreased actually because the carbon tax was taken off. So right now the gasoline prices are lower because the carbon tax was taken off. And then so that's an example of a subsidiarity hierarchy. So kind of a beneficial way of organizing things that can help with the future potential or likely declines. We know they'll happen eventually. We're just not sure exactly what the timeline is. So this is an example of a business as usual financial collapse if we don't do anything. And so then, anyways, people have near full sustenance. So they just cut luxuries, not essentials. It's not a big deal, really. Wages drop or stagnate. Unemployment rises. We do have some of that in some places. And but this would be kind of later on. Percentages of income on food, 30 to 50%. So that's the 2025 to 2030 area. The kind of people are squeezed but not starving. So it's not really that big a deal if it does happen. So 2030 to 2035 will be a great time to invest in rail, and this is just kind of an example of something we could do during this time, because right now rail is not economical, but if fuel prices get to $4 per liter, then it can become worthwhile to invest in rail, as people would be willing to use it. And so at that point, we might experience something like a commercial collapse. Now, this is if we do business as usual and we don't do any restructuring. So then there could be like black markets and lower food, like Soviet bread lines kind of level, jobs scarce, percentage of income on food, 70 to 100%. So this would actually be the 2035 to 2040 years, if we're looking at those kinds of percentages. And so, for example, the 2035 to 2040 years, oil production declining at 2.1% a year, if that happens. So gasoline prices would be $5 to $10 a liter. Industrial food prices, as in from industrial agriculture, would be going up 8.5% a year. A median household would be spending 70% on food. This is what's like the French Revolution, 70% on food. That's so you want to have 25% of people village homesteading to avoid major issues. So these are just examples of food expenditure on food income. So usually most revolutions happened when it was about 60 to 70% of percentage of income was spent on food. But back then also housing was cheaper. So that's just something to keep in mind. And then so currently these are land deformed debates, 40, 45%. They're not revolutions, but when it gets to those, then people start asking questions. And so hungry people revolution. And then if it continues going as business as usual, instead of having human right to land or any kind of restructuring, then things could, get worse. Then the government would fail, and local would turn into kind of a distributed system. But then in the 2040 to 2045 range, we could do hydrogen fuel. And also another thing I forgot to mention, that 2035, we can actually start doing deep geothermal across most of the globe if we do the proper investment, closed loop deep geothermal. So by 2040 to 2045, we can do Fischer-Tropsch fuel if the gasoline prices are $10 to $20 a liter, because then it becomes economical to actually do it. Industrial food prices would still be rising, and then 50% of people would have to have land to grow their own food at this point. Otherwise, society would collapse. And then social collapse, this would be, even worse. And then basically 2045 to 2050. If we go based on that 2025, we'll be living in a rural paradise where 75% of people will be homesteading in villages, and we'll have biofuels, or actually Fischer-Tropsch gasoline, and hydrogen, and it would be really nice. But for the business as usual people, it would be not so nice. Cultural collapse. Okay.
Andrii,
Mhm.
one thing that you have forgotten is about fertility. Today, 2/3 of the country are a fertility rate below 2.1. It means they are going to be toward extinction.
Yes.
Only the South Sahel is expanding, but the rest will be empty in a few decades.
Yes, and actually I found out exactly why that's happening, and it's very easy and straightforward, and we've known it for decades. We have lots of studies like the Universe 25 study. It shows whenever you have overcrowding, whenever you put mammals in an overcrowded setting, they stop reproducing after a few generations. And so because we started having land consolidation in the 1970s, which was also the first peak, since then the fertility rates have been declining everywhere globally, and so the solution is simply giving people land, and then if they have land, then they will reproduce. Like they did it when they did the Japanese land redistribution. During that time they had a fertility rate of 7, whereas now it's well below 2.
Andrii, I think it's what really interested me was in the middle when you're talking about what percentage you pay for food and how that seems to initiate revolutions.
Mm-hmm.
And I would turn the paper or whatever this is, the presentation, around and say the relation between food costs and revolution, and then develop it historically, which it seemed like a pretty good case. I don't know, and then talk about how this is likely in the future because of oil constriction.
Yes.
So I'd start with the middle and then develop your argument. What are you going to do with this?
Oh, right. Well, this is just a presentation I developed earlier, kind of to explain what's happening, and it does explain that the food price increases here are based on the decline percentages.
Charlie, there's some real world examples. Look what happened back in from was it 2006 to 2010. Was it July 15th to 2008? Oil was $147 a barrel. There were riots all over the Middle East, Tunisia, Egypt, you name it. And that was directly the fuel tied to food, because all those countries in the Middle East, they import massive amounts of food, and it caused riots. It's a fact that the real world examples of it happening. I forget what they called it.
I think that
the name of that riot they called it.
We're coming. 1 minute, literally. Sorry. Can I interrupt very briefly, Andrew?
Sure.
Excellent points from everybody. I've got to leave because of other things here. I will put a paper together, a quick draft, Charlie, get it to you within a month, and then we take it from there. We'll put in, I like some of your points, Andrew. We'll put these in as a kind of a separate bit towards the end. 3 pages we're aiming for, Charlie, something really short and thing. Just making the points. I've got to go, but they're excellent points, and I'll try and put in us on reserves, Jean and I reserves, Dan your bit on production levels. And we put a thing, and we're going to be very cautious. No politics, no saying this tax was because of the rich or anything like this. No politics, no thing. Just the uncertainties. Say, look, it's a more difficult world than we think. We have other issues, but these are coming along. And then a bit from Andrea about how society. I'll finish with, don't forget, Hubbard was a clever man. He originally thought nuclear was, once the oil and stuff got short, nuclear was the answer. He changed his mind, and when solar started looking at the solar resource and said, no, it's solar, we've got to go. And of course, solar is effectively infinite. So we've got to put all these optimisms as well as the pessimisms, and we'll cover them just to let this kind of broader debate go forward. Charlie, are you happy with that as a sort of, I'll send you a very rough outline.
Yeah, but I think you're making the topic too wide. I'm not sure. But I guess in discussion, a sentence here and a sentence there. But let's
exactly. So not even a Charlie. Sorry, not even. You're right. Not even a paragraph. A sentence here, a sentence there at the back, including, of course, very importantly, EROI. So we will leave in EROI as an important additional. Yeah, absolutely.
Andrii, I have a similar assessment that I'll send you that shows the same kind of future based on energy return on investment. And what's happening is a perfect storm of declining petroleum resources, declining EROI, and increased social turmoil, which needs energy to support it. So you can't win. Okay.
Well,
okay. I got to go. Andrii, thank you very much for organizing this. Honored to be with such brilliant minds, and well, put my 2 pence in. Thank you very kindly, everybody.
Thank you, Roger. Thank you.
And I know in the YouTube chat, people are very interested in hearing about malnutrition and food security right now. I don't know if anyone has anything on that, but thank you, Roger. We'll see you next time.
Like I said, Andrii, is that during the, like I said, 2006 to 2010, and like I said, in 2008, everybody missed this. In July 15, 2008, oil was $147 a barrel, and futures contracts are 60 days net due. Exactly 60 days later, Lehman Brothers went under, and that's not an accident, because Lehman Brothers was seeking about $8 billion from the banking system. They couldn't get it. $5 billion of it was making good on those futures contracts. And that's what triggered the 2008 financial crisis, was oil doing $147 a barrel. But it caused riots all over the Middle East. You'll find tons of data on that. So there's a direct connection to the price of oil and food.
Mm-hmm. Yes. Yeah, for sure. Yeah, we definitely know.
There's plenty of papers written on it. There's plenty of stuff. If you look for it, you'll find it.
And so someone mentioned Arab Springs, and
there it is, the Arab Spring. Yep.
So could you expand on that?
I don't know the details. I know it started out, I think, in Tunisia with a taxi cab driver. He set himself on fire because the price of gasoline was incredibly high, and that triggered the riots. That's what I've read.
Yes. I believe after that, if I remember correctly, Saudi Arabia started subsidizing local gas. Before that, they had never needed to subsidize it, and this was the kind of the trigger point.
Yep. What about the French taxi cab drivers too? About that time, the yellow vest.
You're right about it. It was a couple of years ago. Yeah, there in France. Yeah, started the riots. Yep.
And Ecuador, likewise. Ecuador has been living high off the hog while the oil production has been going up, but now it's starting to go down. So, Nassif Ahmed has a book on that. That's biophysical triggers of social chaos or something. It's a really marvelous little book.
Mm-hmm.
So that the biophysical things trigger the social violence, and people don't understand that very well. But there it is.
Oh, yeah. I have a question from the YouTube, and it says, what percentage of people will need to have starved before we get our rural paradise? And I would like to say that actually those are two unrelated figures, because we have enough land for everyone right now. The issue is that it's not distributed properly. Just like we have enough food for everybody right now, but it's not distributed properly.
Right. The answer to that, Andrea, depends on your political environment. Some political systems are better adapting to than others. I can say here in the United States, if things get bad enough and you don't like your politicians, we throw them out because some new politician will come along and he'll have a different pitch, and people will go with that guy with the different pitch. So it really depends on your political system and how adaptive it is. For example, in China, that political system is not very adaptive, and that might be a tougher road than, say, in Europe or Canada or the United States. Okay, that's probably the answer to that.
Don't forget that the problem of the world is obesity, it's not lack of food.
Oh, and I actually was doing some number analysis based on fatalities and when a country is willing to concede defeat or something, like based on historical examples of World War I and II. And so the lowest numbers, like France, it had in World War I, when it had 4% mortality of like all men of conscription age were dead, that was considered a lost generation, because, and then I don't remember exactly the percentages that were injured, but I think it was at least 20 to 25% of people had disabling injuries. So that was a massive burden on the economy. But I know like Germany, I think they only gave up in World War II when they had 50 to 60% of people injured, and about 20% dead of so it depends on when they will give up if it goes through the force, to try to answer that question more directly. But I think that basically if we have a movement of people who are interested in human right to land and raising compassion and kindness and stuff like that, we will probably be able to gain enough momentum in the early 2030s for that, because there will be enough of a squeeze on people in like the developed world to do that. And then we do have lots of historical examples of where that went well, like in Taiwan and Japan. It's just that I read this really good book. It's called Land Wars by Joe Gouldy, and it explains the kind of the ebb and flow of where there's like, since that there's many land distribution movements historically, but then since the Industrial Revolution, especially in the UK, there's been a lot of land consolidation, because they wanted to get the peasants off the land so they could get the sheep to make more wool. And so that they started the land enclosure acts and then forcing people into the cities. And now, there's like these narratives saying that, oh, people moved to the cities voluntarily. That's just not true. They were forced out through policies that made it impossible for them to continue living there. And then there was a short period of time just after World War II, all of those people were injured and people were like, hey, you know what? We should try to find a more peaceful way. And that's when they were promoting this land distribution bit. And it was working for a while. But then when China under Mao did land distribution, after that, it was considered communism to do land distribution, even though the US had been doing it for decades. But when Mao did it, it now became communism to do it. And so since the 1970s, the US is like, no, only land consolidation. We have to take away land from the poor and give it to the rich. And that was kind of and it's been the pattern ever since. And it's been kind of getting worse with real estate investment trusts and things like that. And so now in most of the West, it's between 1% to 3% of people that still own land. I hope that helps. And then, here, I have a graph on prevalence of malnutrition, which is a proxy for net energy. And this one is from ChatGPT and based on FAO, Farm Agriculture, from the UN. And so here it's got the percentage of global population. And so you see for most of the Industrial Revolution, it was declining because we were getting better and better at producing food. And then in about 2015, it bottomed out, or 2014, depending on, how accurate you get with the numbers. And then it started to climb again. So 8.5, 9, 9.1. And so there you have the numbers. And what's interesting, though, is that Grok has different numbers for this, but ChatGPT I find is generally more reliable. Anyhow, so because I know the viewers were asking about that. Okay, and I know Ivor is here as well. Ivor, did you have some comments or questions?
Sure. Remember what Gandhi said. There's enough for everybody's need, but not enough for everybody's greed.
Yes.
I think that's what you're saying, and I think it's very true. You know, I mean, it's hard though. You know, the agricultural thing is kind of difficult. You know, I know we had a piece of land for 20 years, and you know, tried to make it pay and stuff, and it did pay. You know, in the end, and it is a great thing to do. But you know, you have to figure out a way that it works in a regular person's like lifestyle. You know, so this piece of land that we had provided us with, you know, maple syrup and shiitake mushrooms and heat for our houses. And so it worked out really well for us as a little useful farm, whereas having a whole bunch of hay fields and having different things like that, you know, it just requires too much capital for the average person to have it, you know. So it's hard, you know, it's hard to figure out a way to make a piece of land work for you. But I mean, woodland worked for us. So that's all I have.
Okay. And also audience question on if anyone has anything on how do the energy and water requirements for AI GPU data centers affect the picture? Does anyone have any data on that? Dan, maybe you?
Yeah, they're energy hogs. I don't know how else to put it.
Yeah.
I mean, right now we got a situation on our power grid that we're not able to expand data centers out on our power grid because our power grids become too fragile. So what these guys are doing is they're choosing to like bring alive old nuclear fired power plants, like up in Michigan, bring them alive and put the data center right next to the power plant just so they can avoid the power grid. Down in Texas, they're putting together gas turbine facilities that right next to the data center, you know, because there's plenty of natural gas down in Texas. And so the point being is we've got to the point where our power grid is fragile and we can't add any more, you know, data centers, you know, to it. So right now, basically, and what's holding up AI right now is the fact that there's a shortage of gas turbines, like the thing behind me. General Electric now has basically the lists are going out like 4 or 5 years. In other words, you got to wait 4 or 5 years before you can get a gas turbine to start your data center project. And of course, nuclear power, any new nuclear power, you're still talking, even with what President Trump's doing and streamlining the system, just setting concrete in place to make sure the concrete's set correctly to shield the environment from the gamma radiation from a reactor, you're still talking 10 years to build a reactor. So the point, what's happening in the United States, literally what's happening is AI is kind of grind to a halt because we can't build and expand data centers due to power. So that's the short answer.
Wow. Well,
which kind of goes back to what I'm pushing, Andrew, and that is what I push is do these geothermal things. The geothermal power plants aren't big enough for the data centers, but they're big enough to take towns off the power grid. You build your geothermal power plant, run it at full power. It'll drop the cost of electricity for a small town, say 60,000 people, 100,000 people, you know, a town that's got like 50,000 houses, and your cost of electricity can drop all the way down to $6 per megawatt hour because you can run this power plant at full power. And on top of that, it's small enough to where a town can take care of this infrastructure. So one of the better ways of doing it is not trying to expand and build your power grid and power plants up. Go small, build things smaller and atomic, and they're much more reliable that way. That makes sense. Yeah.
Yeah, I've heard that that Memphis is having big troubles with Elon Musk's Colossus. They're sucking up all the energy.
Yep.
There was an article. I'm not going video just for continuity here, but George speaking. There was an article, I think BBC on the 10th of July that came out explaining 400 yards from a data center, they have no water pressure. So when they've gone into the more rural areas where they're tapping into the local aquifers and stuff, they've completely drained the water. It's happened a number of places. But yes, there was an article in the BBC on the 10th outlining one in Georgia that this had just happened with. And while I've got audio, to piggyback on your observations of rural versus urban and children, I think I live in a rural agricultural area still, and there is a definite children being an asset versus children being a liability, right? They work, they're required in the city, they have to be managed. It's a different world. It's palpable.
Mm-hmm. Yes, that's also part of it for sure. And here, I just had a graph on the deep geothermal and the costing of materials. So the most economical is I think the bimetallic carbon plus 316. And so you could go down to 7 to 8.5 kilometers here, which covers more than 50% of the globe, if I remember correctly. So, and anyhow, here we go. And then it will last for 100 to 200 plus years if it's set up correctly. And so that is very kind of easy and doable. And it can support very high temperatures as well.
Yeah, the one thing, Andrew, is kind of pointing out there, and one of the things I point out to people, especially about the geothermal thing, is you understand when you talk about the cost of these projects, you amortize the cost over the length of the project. So when you're talking about a nuclear-fired power plant, you're amortized the cost over 50 years, or a coal-fired power plant, or whatever. But these geothermal assets last a very, very long time. That means that you can amortize the cost over a longer period of time, and therefore the actual cost per year is actually really low compared to any other energy source you might invest in. Even though wind and solar are very inexpensive, the problem has to do with their lifespan. That 20 to 30-year lifespan versus geothermal, which is rated in hundreds of years. And that makes it more attractive. And I understand you got that chart there, basically what their current development is, right? But I'm here to say that if I simply take a trip down to Houston and borrow some of the equipment that we use out in the Gulf of Mexico and put that on a barge and drag it up the Mississippi and the Ohio rivers, I'm pretty sure there's a bunch of plants that I could convert over to geothermal using the oil and gas as hardware. And the reason why is because most of these thermal power plants are always located next to rivers, lakes, and the ocean. Mm-hmm. Right. And those are the machines I'm targeting, the old coal-fired power plants, basically.
Right. And so I do have one on comparing deep drilling technology, and EROI did do proven at 5.5 kilometers in New Mexico. And they believe they could do it deeper as well. Using it is close to like it's an enhanced rotary. Conventional mud is may not be as fast, but it's just kind of a similar system. And so we do have the technology to go that deep. It's just that here, if we look at the current historical depth milestones for geothermal, and then I just did this reverse regression here. So the St. Deep one heat, it didn't work out. It was an EGS. And then there's a Sazel-free EGS in Poland, which is also very deep, just over 6 kilometers. And well, I don't have high hopes for it just because St. Deep one heat also didn't work. And because of the geological processes that happen. But the closed loop, I have a good feeling about here. They're doing one at 4.5 kilometers deep, EROI deep in Germany, and it should be online this year or next. So we're kind of waiting for this one. If this one gets approved, then we could go along this, and then we could get to 6 kilometers, 7 kilometer, 8 kilometer. So 7 kilometer by 2035. And then 7 kilometers would give us 50 to 60% of the globe. So we would have to, but we'd have to, implement this at a fairly, large scale over at least many different areas. But at least the early adopters will be ready for that time where, say, in the late 2030s when the food prices may reach 70%.
Yeah, usually how this happens, and this goes back to human nature, it's usually not the first one, the trendsetter. It's usually the follow-on, and then everybody follows after that. So,
Andrii, can you send me that PowerPoint?
Yes, I can also send you this PowerPoint. Yeah.
So it could go at my point is it could go at a constant rate, Andrii, or it could be an explosion. For example, like whenever cell phones were proven out, it didn't take long before every country in Africa avoided landlines and they just implemented cell phone towers because it was better technology.
Yes.
So it could happen a lot quicker than what most people think.
Yeah, and in some ways, this closed loop is the kind of secondary technology, because EGS was what everyone thought it would be, but it just doesn't seem like the geomechanics is working out below 4 kilometers.
Right. I've heard. Give you an example. You talk about drilling. The state of Texas has more than 1 million wells drilled. Think about that. And like I said, I'm dealing with thousands of wells drilled over in Ohio. And if you're talking about a resource that's going to last for more than a century, it's not if, it's just when. And like I said, it won't be the first one; it'll be the second one. Then about the third one, then it'll start catching on. It'll grow.
But the economists will discount the future.
Yeah, they always do. Just like the economists never consider oil production in their economic formulas, which is madness.
Yeah. Okay, and so. Entropy Juggler from YouTube says, do you have data on energy usage for municipal water systems? In the UK, the water sector is the 4th biggest energy user. Does anyone know about this? No. Well, I would like to say that if we do go over to the rural lifestyle model, the easiest thing is water cisterns where you're catching rainwater. And for the vast majority of areas where you're able to grow food, you're getting at least 1/4 meter to 1/2 meter of rain all year, and so you'll be able to get all your drinking water that way.
But in the United States, the food production is that's a really good question, because all the middle of the United States is running off of the Glala aquifer, and we're reducing it down, requiring more and more energy to pump the water up. And meanwhile, the upper aquifer is compacting so it won't recharge. And we're absolutely destroying the whole system. And it's all based on groundwater. So
yes,
the United States is very wide, and the middle of the country doesn't get much rain.
So like Charlie here in the Midwest, here in Indiana, Ohio, Michigan, we grow a lot of corn in this part of the country, but it's for ethanol. It's not for food production.
It's crazy.
So there's a lot of farming here in the United States. It's like misallocated because it's being funneled into alcohol for producing transportation fuel.
I just gave a talk at Canadian Club of Rome 2 weeks ago on energy and agriculture. If anybody's interested in seeing that, I have the video.
Give you an idea, Andrew. Here in Indiana, we sell E85, which is 85% alcohol, 50% gasoline. Right? It's 50%. It's 50 cents cheaper than gasoline is, and gasoline is like $3.29. So you can think about that. The E85 is cheaper than gasoline here in Indiana.
But it takes 1 unit of fossil fuel to make one unit.
That's true. It has less energy content. You get fewer miles per gallon.
And the reason it's cheaper.
No, but the energy cost of doing the agriculture and the distillation is the same as the energy, chemical energy in the product.
Yeah, that's true.
Yeah.
But the reason why it's so cheap here, Andrew, is because we farm so much corn.
And the reason you do that is because the government subsidizes it.
Bingo.
Yes.
If you take away
And
the
it's
subsidy,
really depressing.
Exactly.
I drove across the middle of the United States a couple of years ago, and it's so depressing in March and April, because from horizon to horizon, there isn't a stick of natural vegetation to support the wildlife. It's all just you drive into a town, and one end has all the petrochemicals to grow the stuff. The other end of the town has a refinery, and everything in between and all out to the outskirts to the next town is mud, getting ready to be plowed to make gasoline with no net, make alcohol with no net energy. It's really, really a stupid thing.
It's true.
It's sad. And if you look at the cancer rates at this point in time, now the map clearly shows the highest cancer rates in the country follow the Midwest use of glyphosate. Roundup, basically. Monsanto, or now it's Bayer, I believe. But and we get corn sweat, right? So people don't talk about it a lot, but the corn will stock and exude about 4 gallons a day. So it actually completely messes with the meteorological system that we have in the Midwest.
It causes our humidity be a lot higher than what it should be,
which affects east and west and north around us, because we kick up way more humidity. We don't capture the carbon. And then the fall harvest is a huge problem as well. But if you follow the cancer rates based on our agrochemical use in the United States, it is straight through the corn and soybean belt. It's scary. And the farmers, are the ones that are subject to this, and their children. And now they're also subject to, I call it corn rape, excuse the expression, but it goes back. You saw it happen in Canada first, and it's fully in effect in the United States now, where you cannot go to market based on genetics without paying your be due. So it's a sad situation.
Yeah. Oh,
I didn't understand that. Would you explain your last sentence, George?
Yes, specifically, Charlie, what part? I apologize. I kind of went on the... Oh, okay. So we're applying to the, excuse the slang of corn rape, but basically there have been a number of cases now. There's a great movie out there, as it started with a Canadian farmer, but they've now gone through the Supreme Court, and you have genetic rights. So if I plant heirloom corn in my field, basically, and it cross-pollinates with the dominant strains, the Roundup Ready strains of the neighbors, and I want to take my corn to market, and they show that I am genetically, mutated too much, and I have a better genetic makeup or closer genetic makeup to the Monsanto or the Pioneer or Beck brand corn, then it is legally their corn, and I must pay tribute. For lack of a more thorough explanation. And it is also, everything is now non-germinating. So the old sell a third, keep a third, right? Eat a third. It's impossible to do anymore. Everything's non-germinating. And what they don't talk about in the corn sweat is the potential. It's not really been studied too far yet, but we're also inhaling this water that is coming from genetically modified plants that are able to take these cancer-causing chemicals that will kill everything else around them except for them. So they basically have engineered the corn and the soybeans so that you can dump poison on it and it will live. And we sit here and inhale the vapors, the water vapors from those plants all day long.
Yeah, like the glyphosate. Well, they're known to kill gut bacteria. But Charlie, I have a question. Someone wants the link to your Club of Rome Canada presentation. If you could, if you could find that.
You muted, Charlie.
And I will send you the links to the particular films or a couple articles that cover more in depth on the Supreme Court decision and the agricultural rights.
We have studies, Andrew, from a number of our universities around here that if we switch our crops from corn back to crops that you see in the supermarket, like your squashes and tomatoes and things like that, we could dramatically reduce the amount of pesticides and even fertilizers just by going back to regular crops like tomatoes and cucumber, things like that people actually eat in the supermarket and use less, better for
And
the country. So
it would be cheaper because the government, all they have to do is stop subsidizing corn. Or
yeah, because
lower
we're
it.
growing it here locally, it goes to the local supermarket,
Yeah.
not from, you know.
In China, they use American corn as fertilizer. They don't even eat it. They import it for fertilizer.
Yeah.
Because they don't consider it food grade. But yeah, in terms of what Charlie was saying about depleting the aquifers, and that's another reason why I say that the kind of the future is rainwater collection cisterns.
Now that's true with like Nebraska, Oklahoma, Kansas, North and South Dakota, Texas, right? But where we're at, we've got, like I said, the Ohio, the Great Lakes, and you know, so our water situation is different. But it'd be better if we just switch what we were growing and not growing GMO engineered soybeans and corn.
Yes. And then if people basically like the future, there will have to be a fairly radical transformation in terms of from growing this corn to growing forests, food forests, because food forests require fewer inputs and they attract rainfall. Like there's many studies on this. And so that you actually increase the localized precipitation, you reduce the amount of evaporation. If you have, like, say, a 10-kilometer or a 20-kilometer radius strip, it creates its own clouds, and it has its own, like, it rains on itself.
One of the things that's happened, like the southern part of Indiana, south of Indianapolis, right, is the state has bought back a lot of farmland, and that's exactly what we've done. We've increased the amount of forest that we grow in this state, and we did it for exactly what you said, because it attracts more rainfall, and on top of it, you don't have a lot of the soil erosion issues that you have. So you'll find that some states are more forested than others, and this is one of the states that's even more forested now than what it was a century.
How can corn increase the humidity of the air compared to forest?
What they did was they bought back the farmland and let it grow forest trees.
But when you increase, somebody said earlier, George said earlier,
he's talking about if you go from north of Indianapolis north up into Michigan, it's all farmland. And George lives on the north side.
Does the corn transpire more than a forest?
Yeah, it does. It transpires more humidity. It makes the air more humid. Increases the humidity levels because
the water absorbed through its roots is then released into the atmosphere through its pores, and it does that.
I understand that, but compared to a forest, that's
much
forest. You end up with this mat down at the bottom that's like a sponge, and it holds in the moisture. It's a lot different than all the surface area of the corn just evaporating.
Yeah, it's a meteorological phenomenon in the summer that whole corn belt has something. What do they call it? Corn sweat.
Corn sweat.
And it's in the middle of the day.
Yeah, no, my wife was just in Indiana a month ago and for a wedding, and she was amazed at how humid it was.
Yeah, it's super humid.
Yep.
Yes, you can drip sweat in the shade with a breeze. It's amazing.
Yeah, we've got data that goes back into the 19th century that has measured the humidity levels, and the corn has made an impact. Not a good one.
Okay, I think I got to go now. So
I've got to run myself too, guys.
Okay, sure. Yeah, we'll round up. I just had a last thing from just showing the fertility rates. This was mentioned earlier, showing that Africa is the only place that's growing. Everywhere else is declining.
Yep.
All right. So as we met you, we leave you in the infinite love and infinite peace of the infinite creator within you and all around you, my friends. Go forth, therefore, rejoicing in the infinite power and the infinite peace of the infinite creator. All right. Thank you.
Thank you all for the knowledge.
Thank you all.
Okay.
Thank you.
Bye.
Bye, John.
Okay. I've ended the stream and